So within the field of consultancy and civil engineering, and in particular in geotechnical engineering, which is where my background is, then the challenge really is in terms of collection of site investigation data, improving and enhancing the procedures there, and then developing design parameters and carrying out design works. And generally these are multidisciplinary design works, so we interface with a lot of other people doing these bits of design. And then the challenge then goes on to the problem of construction and supervision. We start off with Raoul and his work on instrumentation, and that was to speed up the stage between achieving good quality improved instrumentation processes, so that it then takes good quality and back analysis and improves that parameters, and we get better case histories. Mike Pledger is focused in the stage before that, which is whether we want to use 2D or 3D analysis. So it's focused on improving our numerical procedures. Artemis is slightly different. One of the areas we're interested in is nuclear waste disposal, and so that process, it's a £10 million repository or hole in the ground, 500 metres below the ground surface. We don't know where it is, and it's a very challenging, interesting geotechnical project, so we'd like to be part of it. What is difficult today becomes routine today, routine in 10 years' time, and you can just look at what we used to do, and we're doing things now that 10 years ago that we just wouldn't think we would. It was beyond our dreams, so to speak. So I think that process will continue, but that is a very big challenge, and needs to understand how we then have this mismatch of rapid development where older people don't understand new things and younger people might understand them but don't understand the construction risks, and how you keep bridging this gap of a rapid technical development is a difficult process. I would suggest anyone embarking on engineering needs to think about which university they're going to, and what their end goal is. As part of the Institute of Civil Engineers, we had a group trying to look at knowns and unknowns and uncertainties, but it went back to the underlying root was the way in which effective stress and soil behaviour and properties is taught in universities, and the concern was that 20 years on we actually haven't embraced a good way of telling the story about soil as a material, as dilatant material when it's over-consolidated, normally consolidated, and all this soil behaviour. And we have, if we could get that across quickly, then we could then get into complicated soil models, and people would come out of the university with a clearer vision and understanding of what soils were. Whereas I kind of feel they come out of it and haven't really got a good understanding of the basic principles of effective stress.